Hi, fourth grade friends. We're going to continue with division and we're going to use the area model again. What's really great about the area model is that it combines multiplication and repeated subtraction, something that we're really great at. In addition, it also breaks the problem down into smaller parts. Now, something that I'm going to share with you today is that when we divide this together, we're going to find out that there's actually going to be remainder, something left over at the end. So I want to show you what do we do with that remainder and how do I use it when I check my work with multiplication at the very end or when I'm completely finished solving this problem. Okay, now I'm going to draw a model down here and I'm going to divide it into three parts. Okay, this part I'm going to have as my hundreds place, my tens place, and my ones place. Okay, the reason why I'm doing that is because I have a hundreds, a tens, and a ones place here. I'm going to put the 5 over on the side, and I'm going to put that number 441 inside my model. Now, I want to be as efficient as possible, so I need to be thinking about what multiple of 5 can I use, and then multiply it by 10 to get me really close, if not exactly, on 400. The reason why I say 400 is because I know I have the digit 4 in the hundreds place, and that 4 represents the value 400. So let's just think about that for a second. Let's do 5 times 50. That gives me 250. Still not quite 400, so let's go even bigger. Let's try 5 times 60. Well, that will give me 300. I'm still about 100 off, so let's just keep going and see if we can get even closer. 5 times 70. 5 times 70 will give me 350. Let's just try one more time and see if we can get even closer to 400. 5 times 80. 5 times 80 is 400 exactly. So that's where I'm going to start. I'm going to put that multiple of 10 up here, 80, and I'm going to multiply it by 5, and that will give me 400. Okay, that's where that multiplication comes in, and then here's where my repeated subtraction comes in. I need to subtract 441 minus 400, and that leaves me with 41. I'm going to move that over, and I'm going to think about that digit 4 that's in the tens place. That digit 4 represents 40. Well, I know that if I multiplied 5 times a multiple of 10, like 10, it will give me 50. Well, that's already too much. So I'm just going to skip count by 5s and see how close I can get to 40. 5, 10, 15, 20, 25, 30, 35, 40. I actually land on 40. Okay, so that is 8. So I'm going to multiply 8 times 5, and that will give me 40. And then I'm going to subtract, and I'm left with 1. Now, if I skip count by 5s, I'm already larger than 1, which means this has to be a 0 here. So 0 times 5 is 0. And when I subtract, I'm left with 1. Okay, that is in fact a remainder. There is just 1 left over. If we were thinking about this in reference to cans and boxes, there would be 1 can that just doesn't quite fit, which means Kate would probably have to go and buy another box so that that can would still be accounted for. Okay, but how do I represent this if I were to complete this equation up here? Well, all I have to do is add up these partial quotients at the top, 80 plus 8 plus 0, and that gives me 88. And then I put my remainder 1 here. So 441 divided by 5 is 88 remainder 1. Now, let's check our work to be sure, and I'm going to show you what I do with that remainder when I'm checking. I will still multiply 88 times 5. 88 times 5. I'm going to use the standard algorithm for multiplication to check. 5 times 8 is 40. 5 times 8 is 40 plus 4, and that gives me 440. I will add 1 to this, and that equals 441, which is exactly what I was hoping to get. So whenever you are dividing and you're left with a remainder at the end, okay, when you're checking your work using multiplication, you cannot forget to add the remainder on to the product that you got here.